Hello, good evening. I'm going to give it 20 seconds for people to log on and join us before we go ahead and get started. Okay. All right, so we got people logging in. All right, we'll go ahead and get started. Good evening, everyone, and welcome to tonight's Water Matters webinar. I'm Senior Public Affairs Specialist Laura Gallegos, and we're so glad you could join us. Tonight's webinar is all about the 2025 Consumer Confidence Report, and we will be talking about water quality in the Santa Clarita Valley, a topic that affects every household and every drop in the water that we use. We'll be breaking down some key highlights, what they mean for you as a customer, and what SCV Water is working to ensure safe, reliable water every day. We're excited to introduce our speaker tonight, Jenny Anderson, our water quality specialist here at SCV Water. Jenny has been with the agency for 9 years now and brings a wealth of knowledge and experience to this conversation. She's deeply involved in monitoring water quality and making sure our system meets or exceeds all state and federal standards. After the presentation, we'll have a Q&A session, so feel free to drop your questions into the Q&A box at any time. We will get to them at the very end. So let's get started. Jenny, take it away. I'm going to be turning my camera off, but I am here.
Perfect. Thank you so much, Laura, and it's nice to be here today. So as Laura said, we're going to be exploring the 2025 Consumer Confidence Report and the water quality in Santa Clarita Valley. I'm Jenny Anderson, and I'm a water quality specialist at SCV Water. So our session overview, we're going to be discussing who we are, some water quality monitoring, water analysis, tackling PFAS contamination, regulatory compliance and reporting, common water quality calls, and then at the end, like Laura said, some Q&A. So who we are, we formed January 1st, 2018 by an act of the state legislature, Senate Bill 634. And prior to that, we were different agencies operating separately. So as of one now, we span approximately 197 square miles. We go all the way up the 14 towards Sand Canyon and Canyon Country, and all the way left to the 5 freeway over by Castaic. We serve approximately 300,000 people, and we have over 75,000 service connections. So we are a larger agency. Water quality monitoring. So we have a lot of abbreviations that we go by. Here are a few of the more commonly used abbreviations for water quality parameters. So like, for example, we're looking at DBPs or disinfection byproducts. Just an example, those are formed when disinfection like chlorine interacts with natural organic material in water, and then they create TTHMs or total trihalomethanes or HAA5s, haloacidic acids. So some ways we reduce these DBPs in the system is to shorten water detention time and to reduce the contact time and or the concentration of the chlorine in the distribution system. So as we start talking about the distribution system, here's some pictures of some sample stations that we use throughout our distribution system. You may have seen these on your walk, you may have driven by them, and may not exactly have known what they are. They're actually connections to our distribution or our water mains, and so we're able to utilize these, flush them, and then can take real life samples and be able to monitor the entire distribution system from one side of the valley to the other side. And with that information, we can go to the tanks, see what's going on there, and then also be able to chlorinate or take preventative measures as necessary. So this is really great for our representative monitoring. And so with that, we do have 88 sample stations that do collect total chloroform samples and also including temp and chlorine weekly. We'll go into total chloroform in just a little bit. We do collect 27 general physical samples that include pH, color, odor, and turbidity. And just for the knowledge, we do have 107 tanks spread throughout the entire valley. Generally, those are the ones you'll see on the top of the mountain, but we do have a very robust system. So in addition to our distribution monitoring, we also have source water monitoring. And source water, we monitor for like the raw surface water at the Castaic Lake. We don't actually monitor at the lake per se. We do have a faucet that we utilize within our lab so that we can collect those samples. Then we also have 2 treated surface water plants. One is Jerry Gladbeck, which is over by Central Park, And then we have Earl Schmidt, which is right beside Castaic Lake. And then we also utilize groundwater wells. So you can see we have various ways to source water monitoring. With that, we have specifically for our groundwater wells, monitoring is unique and individual to every single well. And what I mean by that, it's based off the concentrations that we see within a well. So certain wells have increased monitoring for a constituent that others do not. And in addition, there's also a vulnerability assessment that the Division of Drinking Water, that's our regulators, for each well, that is again dependent on that site. So what's interesting, like on this slide, you'll see like the weekly and the quarterly both have PFAS and perchlorate. And what does that mean? It's based off the vulnerability or the potential detection or the detection that's already been seen at that well. So a lot of these wells that may have PFAS or elevated perchlorate, if they do have a treatment facility, like with ion exchange, we will be conducting more samples. So that would be like a weekly sample. Whereas if we had a well maybe upstream that has never had a positive or detection for perchlorate or PFAS, that might be a quarterly, or it could even be annually, depending on what that influence is around that area. So you can see weekly is probably the most robust that we would do. Now, if we shift to surface water, so our treatment plants, there's even different monitoring over there. And for a surface water treatment facility, they have extensive monitoring that occurs as often as every 4 hours. So you can see it's very different, it's broad, and just depending on what you're looking at, it's going to be different rules and regulations per the Division of Drinking Water. So water analysis. Here are some analytical definitions that we frequently use. So not to go through all of them, but AL at the action level, that's referring to the highest allowable limit for lead and copper concentration. You'll often hear DLR or detection limit for reporting. That's a reporting limit that uses the EPA lab method in terms of detecting the lowest quantifiable level. And then we have like an MRL, which is the minimum reporting level that an instrument within a lab can quantifiably detect with confidence. And then as you can see, we have like a couple of our two treatment plans. We have the Jerry Gladbeck, we have Earl Schmidt. We'll go over some of the units in just a bit. So for analytical chemistry, it's the science of identifying substances and how much are present in a sample. And this, it seems simple, but it actually becomes really important. So example, if I was looking at qualitative, if I was walking down the street with a bag of white powdery substance and a police officer saw me, it would be really important to know what that is. Is it baking soda or is it something else? The cop would want to know. Similarly, quantitative. You see that bar right there of gold. Is it pure gold? Is it 100%? Or is it plated gold? So for a police officer, just like in chemistry, it is really important to identify the what is it along with how much of it is there. So when we start thinking about the analytical, we want to start thinking of concepts. So parts per what? This is a great example, super easy. We have one pink sprinkled donut in a box of 12. So 1 part per 12 or dozen. Similarly, you see 6 glazed donuts. That would be 6 parts per dozen. So if we break this down a little more, we do percentage. So we have 1 penny or 1 cent of 100 cents. So that is a percentage of a single dollar, 1 cent of $1 or 100 cents. So when we start going deeper into how much, we think of how little 1 in a million or parts per million really is. So we're taking it again to another level. So just so high level, you have 1 minute in 2,000 years. That's 1 part per million. 1 penny in $10,000. You have 1 inch in 16 miles. So with that, you break it down to parts per billion. You're now looking 1,000 times less than what you had in a million. So instead of the 1 minute per 2,000 years, you're now looking at 1 second in 32 years. 1 penny in $10 million. 1 inch in 1,000 miles. So if you think of just how minute and how small we are going in terms of the parts and quantifying it, it's getting less and less and more smaller. So take the parts per billion, now 1,000 times less, parts per trillion. So we're going to be going over PFAS in just a bit. That is a constituent or a contaminant of concern that I mentioned just a little bit ago. We are quantifiably able to detect PFAS at 1 part per trillion. So in reality, what does that mean? We're looking at 4 grains of sugar in an Olympic-sized swimming pool. I mean, if you really put that into perspective, I probably couldn't see 4 grains of sugar on my countertop. So you're talking 4 grains. So you're seeing what instrumentation within a lab is capable of doing and just how tiny a part per trillion really is. And I can only imagine as technology advances, this is where we're at now. Where are we going to be in another 20, 30 years? So when we look at all of that, how do we put that all together? So what do chemists really use inside a lab? We use mass per volume. So it's very similar, and it is actually equivalent to this parts per million, but instead of that, we're going to be looking at it in milligrams per liter. And that's what we receive on our lab report. So example, that PFAS we were discussing, that's parts per trillion. That would be in our lab as a nanogram per liter. But again, keep in mind, 4 grains of sugar in an Olympic-sized swimming pool. So you can see just how much we're able to actually identify in such a small mass. So water quality testing. What is the most important water quality test? I would say for us and for most people in water quality, it would actually be total chloroform. The chloroform family is a vast family, and it doesn't only just include total chloroform, but there's subsets to it. And one of the subsets would be fecal coliform. And then further subset would be E. coli. And so it's very crucial and important that obviously we would not want any type of fecal coliform or E. coli in our drinking water. So when we go out and we collect those samples at the sample station, we are collecting total chloroform samples every single week. So how do we analyze for these total chloroforms? We actually use an incubator that's set at 95 degrees Fahrenheit. And why 95 degrees Fahrenheit? Because we want to mimic what that water would be inside a human gut. And because our temperature is about 95 degrees inside our stomach, that is what it's trying to mimic. So it will be incubated for 24 hours at 95 degrees, and it will allow any of the organic formations and all the changes that could possibly occur. And after the 24 hours, we will take it outside of this color, and we actually put it up against a UV light. And with that UV light, you can see based off the color, one, is it negative for coliform? So it's going to be more of a lighter neutral color, even clear, up to a positive, which would be more of a yellow, potentially even orange color. And then a very good indicator of E. coli would be blue. So very telling and easy to see. So microbiological contamination, these are contaminants that are within that are organisms in water. So only a few are really pathogenic or disease causing. Pathogens are found in intestinal tract of warm-blooded animals, and some examples are like bacteria, viruses, protozoa, and parasites. That's why it's so important to collect these total chloroform samples, and you can see even a picture there of one that's total chloroform negative and one that is positive. So it's really important to collect these samples throughout the week. For viral, it includes hepatitis, polio, gastrointestinal diseases. That's why it's so important that we chlorinate, because it will take care of these viruses and eradicate them so that they're not in the water that we're serving. So I really like this graph. It kind of shows where we were and where we've become. Back in the 1900s, typhoid fever was a real concern. A lot of people did die from typhoid fever, and that was because of waterborne illnesses. However, once we discovered chlorine or chloramines, which is a chlorine and ammonia that still involves the chlorine, Once that was discovered in about 1908, you can see a sharp decline of deaths resulting from typhoid fever to the point where then almost 1950 or right before that, it was more or less eradicated. So chlorine has become the primary disinfectant for water, and you can see the effectiveness that it has on the drinking water. So turbidity, this is a measurement of cloudiness. And this picture shows how turbidity is measured. So you have a light source, a lens, and then it detects out with scattered light. I do have some standards here. So for a picture, it might be kind of hard to see, but in this, oh, where can I show it? Right there. You can see this has a turbidity of 1,000. This has a turbidity, which is almost clear, of 0.1. So we need to stay within less than 0.2 turbidity to make for our requirements per the Division of Drinking Water and per regulatory standards. So you can see the 1,000, it is very hard to see anything through it. It is very cloudy. And that's what this turbidimeter would do, which we have inside our own internal lab. So as we discussed about PFAS, what do you need to analyze for per and polyfluoroalkyl substances, or PFAS? It takes a very sophisticated instrument to analyze down to that parts per trillion that we had discussed. So this liquid chromatography tandem mass spectrometer is actually a picture of our lab over by Central Park, and you can see just the setup that it is. It's very sophisticated, gives us very good confidence all the way to that parts per trillion on what kind of detections we may have regarding PFAS. So tackling PFAS contamination. There is a lot of PFAS sources that are all around us that has pretty much absorbed everything that we do. I mean, it's as far as shampoos, nonstick cookware, stain-resistant products, firefighting foam, the fast food packages. So when you unwrap that hamburger or cheeseburger, that cheese doesn't necessarily stick. It's all that non-resistant items. It's everywhere. It's robust. And the EPA decided that it was going to be part of the unregulated contaminant monitoring rule, or what we call UCMR, during 2013 to 2015, that required all water systems to participate in this UCMR. And it actually looked at certain PFAS chemicals, PFOS and PFOA. Those are two primary ones that people may even hear about. Especially today, I've heard, nonstick cookware, PFOA free. So that's when this first started really being addressed and looked at in water. And with the detections that they saw, they started implementing what can we make rules, what can we start making regulations on. So for California, our Division of Drinking Water in 2018 established the first set of regulations to the PFOA and PFOS constituents within that PFAS family. And then in 2025, they've initiated processes to revise the notification and the response level for not only PFOA, PFOS, but a couple of the other constituents of concern within that PFAS family. So when we did the UCMRs and new rules were starting to come out, SCV Water took a very proactive approach. We did find detections of these two chemicals or constituents. And so we were proactively went and permitted our first ion exchange treatment for PFAS. And it was the first not only for us, but for the state of California. Currently, we have 4 PFAS treatment facilities running and online. And we do have new projects in planning, in design, and or construction to reduce and remove PFAS from our drinking water. We do have in-house testing for PFAS, and we are one of 3 nationwide certified California ELAP labs. So here's a few pictures of the different PFAS facilities that we have. N wells on the top left is to treat 3 wells and brought them back into production. So we have well N, N7, and N8, and this is located over by the ball field. Valley Center well brought 1 well back online. Santa Clara and Holmby wells brought 2 wells back online. And most recently, well Q2 brought a single well back online, and that one's over by the Lowe's off of Bouquet. So kind of as I mentioned, we do have a PFAS instrumentation that's able to test for us in-house. What a real benefit is, we're able to save time as well as money because we are able to do it all internally. And we have a quicker turnaround time on those results. So it's been super effective and a great resource to our lab, as well as ensuring that the water quality that's coming through these treatment facilities are safe. So we did get certified through the Environmental Laboratory Accreditation Program. And just as I mentioned, we're one of 3 water agencies in California and one of 25 nationwide labs to be certified to test and analyze for PFAS. So I'm very glad that we have that. I'm very proud of our lab to be able to do this. So regulatory compliance and reporting. What do we report? We submit to the Division of Drinking Water, so DDW, anywhere from monthly reports, which include bacteriological, so total chloroform, general physical, and nitrification. There's more. Quarterly reports for disinfection residuals and disinfectant byproducts. Annual reports, such as electronic annual reports that we have to submit to the Division of Drinking Water, and then triennial reports for the public health goals, which is required, like I said, every 3 years, but we will be doing that this year. So we've already submitted our report to the Division of Drinking Water, and we will be presenting to the board and the public in the next coming months, I believe in August or September. And we even have reports for our customers. So it's shown there, but we do have, sorry, can't show it very well, our consumer confidence report, which is also required by DDW, that we need to complete and distribute annually by June 30th of every year. By 2027, we are going to be directed to do it twice a year. As of right now, the current report bases off last year's data, but when we start this twice a year, if there's any new data that has come within that first 6 months of the year, that will be added on or used for the second report. So it's available in digital or hard copy, English and Spanish. And we do plenty of customer outreach and outreach efforts. So some of the items that we do is we post it on our website. So if you were to go onto our website right now and under the water quality tab, you would be able to see this consumer confidence report online. We also do legal ads, press releases, media stories that include the Signal and KHTS, Water Currents, which is our electronic newsletter, social media post for like Facebook and for X. And then at all the libraries in the Valley, we have hard copies there too on file. So you can go there and ask for them. If you did want one, please reach out to our customer service department and we would be more than happy to give you a hard copy at any point. So the kind of information is just general water quality information. We talk about the groundwater, we talk about surface water, that vulnerability assessment that I kind of mentioned earlier, any new water sources. So if we were to bring a new groundwater well online, water quality, great information about board meetings, when do they occur, the time that they occur, and any contact information. So if you need to reach out to water quality, if you want to reach out to our customer care department, it's all there for you to view and access. For the technical aspect of it, we go a little more into like the primary health drinking standards, maximum contaminant levels for certain constituents. If we happen to have, total chloroform samples, what were those results? Another thing we do, like lead and copper every 3 years at our customers' taps. So all that information is all there on the CCR. So it's really great information. Also, we have on there is where our water comes from. So just kind of like I mentioned, groundwater, imported water. We also do have a little bit of recycled water, which we are expanding as an agency. So more of that will be coming. And then we also have banked or stored water, and that's primarily more in the Bakersfield area, but that's really useful, especially for our drought season. And it's great for water resources where they can find the best way to allocate the water and what water we use each and every year. This is probably a little hard to see, but it is our water quality data page. So this is a great spreadsheet. A lot of times I get customers that call and say, what's our water hardness? Or, I want to know about fluoride. If you have any of those questions, a lot of this information is right here in this water quality data. So please feel free to take a look at it. It has our minimum, our maximum, and our average throughout the entire valley. If you have any questions, feel free to give us a call and we can go over it with you, let you know if there's near the maximum contaminant level, what exactly does that mean, and assist you in being able to fully read this. So let's go over a few of the common water quality calls that we seem to get. Water hardness. So my water is hard. Does that mean it's unsafe? The answer is absolutely not. It is actually just higher minerals of calcium and magnesium that create a water hardness or hard water. Think of it as like a dietary supplement or even a vitamin. A lot of times people take these as supplements. So as displeasing as it could be in terms of the aesthetics, because you do see spots on dishes, you can have deposits on your fixtures or faucets. It is not harmful and it is not a health concern. So it would not have a maximum contaminant level or health advisory. So why is my water cloudy? Great question. A lot of times it can be water that is pushed through to the distribution or water mains, and there's water air that has become entrained. So what that means is that when it comes out and it releases into atmosphere, which would be your faucet or your fixture, it can come out like that cup that you see where it looks very cloudy. This is different than turbidity because you'll see if you let that cup sit on your table, it will actually clear up from the bottom up. And so that is air being released into the atmosphere. And you can see that it is not a turbidity, it is just entrained air. So air does come up sometimes when we are running our wells, and there's just other times that it just happens to get trapped within our main lines. So why is there a rotten egg odor in my water? Generally, this is commonly seen in a kitchen drain. It can also be a bathroom drain. A lot of times you'll see that there's that P-trap right there, and on the right, it shows that it's filled with water. That's the main objective, and that's what it should be doing. However, when there's gunk and other stuff that gets stuck in there, food, maybe hair, other things that get stuck, that water actually drops because there's other stuff blocking it. So when you first turn on that fixture or that faucet, you have an off gas from the discharge side, and it doesn't smell pleasant. So best way to see if this is actually what you're encountering, take a glass cup, fill it up, walk outside the room and smell it. Does it have that same pungent smell? Or is it maybe that P-trap? And if it is that P-trap, that's probably a very easy fix. You can take a snake and snake that line and get any of that stuff that's causing that blockage. So why is my water discolored? There's a few different reasons. Generally, if we see a yellow water, that tends to be from water softeners. And they usually are because they recently changed out and they're not generally always properly flushed. So if you encounter yellow water and you have a water softener, if you want to do a test just to verify, you can always put that water softener on bypass. There's like a black knob on top. And if you just push it in, then run that water, think about your lateral lines. If it clears up, I have a good feeling it's probably that yellow water from that water softener. If we happen to have a hit hydrant or someone suddenly opened or closed a hydrant and they increase the velocity, you can get discoloration. You can get kind of that brown water that you see in that glass right there. That's when you would really want to give us a call. We need to come out. We may need to do some flushing and assess what's going on over there. If you see a reddish color, that's generally private plumbing from galvanized pipes. And that would be an internal plumbing issue. One way you could always check that out too is if you go to your front hose bib, that's you can see if that's the same color that it is inside. And that's usually a good way for us to detect, is it the incoming water or is it something that's going on internally within the house? And then why does my water have a chlorine/chemical smell? So that could be chlorine. Normally we do use a chloramine, which is a component of chlorine and ammonia. It actually creates a longer, stronger bond. and it tends to lower or decrease that odor that you will commonly get used to or notice. However, sometimes we do need to use free chlorine, especially maybe at the tanks. That does have a stronger odor. The good news is, as you've learned today, that does help take care of any pathogenic growth. It is a primary disinfectant, so it is needed. We do want to reduce any type of potential for typhoid fever and any other waterborne illnesses. So it will dissipate. It does degrade over time. But if there's any issues, you can always give us a call, and we always are more than welcome to go check it out. And like I said, we do analyze, tanks every week. We do go to our sample stations every week. So it is very important that we look at the entire system holistically and make sure that we have good water quality throughout our entire valley. And I think I did that pretty quick. So does anyone have any questions?
All right, Jenny, I will read the questions that are in the chat. We have, what can we do for the very hard water calcium buildup that shortens faucet and shower valves life? Dishwasher buildup, washing machine buildup, ice maker buildup. So, do you have an answer for that, Jenny?
It really depends on what you want to do. I would not recommend anything per se, because it is an aesthetic issue. However, if you wanted to venture out, you could do something as easy in terms of, it's cleaning it more often. You could do something like vinegar. That would be a good one. Bleach. If that's Lemmy Shine, not to really name names, but that one would be good for like dishwashers. If you felt that it was just not something you wanted to deal with, people do go out and purchase water softeners, and they can use other companies that would do so. You would have a, I believe, monthly fee with that, and that would not be something that would be provided through SCV water, but that would be a personal decision if you chose to do something like that.
Um, okay, so another question just came through. Temperature. I understand that the tanks bake in the hot sun and heat up the water. Can anything be done to keep it at least cool?
Um, so historically, it's always been stainless steel tanks on the top of a mountain because it's easy to gravity feed. But yes, excellent question. The temperature does rise, obviously, because it's sitting up there. Recently, and actually just this year, we created our made our first built, excuse me, our first water tank that was made out of concrete and is partially buried. So not saying that that's going to change every 107 water tanks that we currently have, but going forward, that is a concern, and that was something that we thought of. How else can we drop and maintain a lower temperature? Because as you know, if it heats up, water is organic material, and you can have water degradation. Then you're going to have to chlorinate. So it can be kind of, then it's a potential for nitrification. So right now, like I said, we do go to the tanks. If we see potential issues, not only do we dose it, we can go back later in the week and double check it just to make sure it has a good chlorine residual coming out, because heat does increase and drop the chlorine concentration. So yeah, going forward, if we can start doing more of these concrete tanks partially buried, that will lower. But until then, it's you get water moving. If we can cycle that tank quickly, it's not going to sit and it's not going to get as hot. So especially during the summer, that's when more water is used anyways. Higher irrigation's being used, more people are out in their pools, water is evaporating. So a lot of times water is moving a little quicker anyways during the summer, which does help the temperature increase.
Okay, and I do see somebody has their hand raised. If you could please just type your question into the chat, we will get to it then. Next question: is water softener water okay to drink?
Absolutely. It's really just taking away calcium and magnesium. And then depending on what you're looking at, it can take away other constituents depending on what type of, whether it's a water softener or whatever else you decide to purchase. But absolutely.
Okay.
All I would say though, if I'm sorry, I'll interrupt. you are not allowed to buy a salt-based water softener here in this valley. So what that means is anything that creates a salt brine, you are not allowed to purchase. You're allowed to purchase them in the San Fernando Valley, but not here. So if you're going out to any of those vendors, they will be well aware of what is allowed here and what would best suit this valley.
Thank you, Jenny. Okay, next question. Our faucet is flowing slowly. What can we do?
Depending on what's going on, if you have an aerator, I would take that aerator off. You might just have some particulates, some sediment, and that's kind of natural. When we have a main line, you can get sediment after we have groundwater wells running. It's not 100% water. Like I said, you also can have some entrained air. We can actually pick up a little bit of sediment. So I would try to do that first. Use that aerator, take that screen off, and then you can generally be able to clean that out.
Okay, thank you. Okay, this next question has some background, okay? So our home is located in the older neighborhood of Golden Valley exit off of the 14 near Sierra Highway, Friendly Valley, and Abaldi Street. Since 2011, when we purchased the mainline water line in the parkways have burst at least 15 times. We are concerned that the water system will not be adequate if we have a major fire like Altadena and Palisades. The repair teams we have spoken with and called have been saying for several years that the main lines were going to be replaced. We still have a parkway with orange SCWD cones needing drain repair and plans replaced again after the last pipe burst a couple weeks ago. Okay, do you want to kind of tackle that?
I would kind of say that's a little bit outside my realm in terms of, do we have enough water and capacity? The answer is yes. And by that, not only do we have water flowing throughout our distribution system, but engineers, we recently did a whole survey of this entire valley. And part of that hydrology is ensuring that not only do we have enough water for our maximum flow day, but that we also have enough water for our maximum flow day as well as fire flow. However, I don't know exactly what happened in Altadena. We're not there, but I've heard, pipes have melted. If pipes melt, water cannot be used. There's only so much water flow that can happen in a 6-inch pipe or in a 12-inch pipe or even a 4-inch pipe. So if you're using that water, there needs to be time for more water to come through. In terms of water, the issues you were having with the mainline breaks, that would be something I would recommend. If you want to shoot one of us an email, and then we can take it to the operations department and see if there's any future plans. We're really good with like pipeline improvements. We just did recently one over by Valencia High School. Again, it's not my department, so I don't know where that one specific mainline might be, one that is in the future, depending on our budget. But if you wouldn't mind, send us an email and then we could get back to you absolutely and see if that one specifically is going to have a repipe or some type of improvement over there.
Yeah, so if you could just send me a quick email, and we'll follow up with our operations team, and then we'll get back to you. Okay, next question. When I test my water before I run it through my zero waste filter, the meter reads a TDS of 264.
Mhm.
After the filter is O, I live in Castaic. What might those TDS be? Is 0. I think you meant to say 0.
So,
Okay, follow up.
so
What is safe levels of TDS?
well, the safe levels, there's actually three. The low on our consumer confidence report, it'll say the lowest is 500. That average could be up to 1,000, and the high is 1,500 milligrams per liter. So our highest that we saw within the groundwater wells was 940, and our average was 599. But if you go through our surface water, which is the snow melt from the Sierra Nevadas, that average is 310. So we do have a blended system. So between that 310 and that 599 number. So anywhere in between that, technically it can go up to 1,500, and we are well below that upper regulatory limit.
Really quickly, Jenny, could you tell us what TDS stands for?
Oh, sorry.
Okay.
Total dissolved solids.
Okay. All good. In the water world, we talk jargon. So that's just one of the new ones that I I didn't
Sorry.
know. All good. Okay. Um, for the question about repairing your drain and your plants, Valerie, we'll follow up with you on that. Um, we'll get you to the right person and make sure that that's answered. I don't, oh, let me see over here. Okay. Um, okay, here's another question. What are the primary reasons other than cost as to why SCV water would not soften its water before distributing it system-wide to all its customers?
Great question, actually. When I first started, I was at former Valencia Water Company, and we did have a pilot project. This was prior to me starting. That did a water softening demonstration project that served right below that Tesoro community, and it worked very well. However, it was very extensive and time consuming, and the goal that we have envisioned as we merged as SCV Water is to soften the water. However, it is aesthetic. It does cost a lot of money. And even though it's a goal of ours, right now it is an aesthetic concern. And we did not expect PFAS to be such a emergent contaminant as it has been. Like I said, in 2013 to 2015, the EPA required all water systems to start sampling for these constituents that we were very unfamiliar with. And as time has come, within 10 years, I mean, it's an emerging contaminant. We now have, like I said, 4 ion exchange treatment facilities. So it's something that we foresee on wanting to do. But right now, we have to worry about regulatory compliance, and we have to make sure that we're serving water that does not have any potential for causing cancer or any other health related issues. So I would say what we started to work on has been pushed out probably, I don't know, another 10 plus years until we get PFAS under control. And anything, just so you know, that did have any detectable PFAS, PFOA, or PFAS, or FOA or PFAS concentrations that were at that above the notification level or near that response level that they've now regulated, those wells have been taken offline. So we are catching up since that 2021, 2022 of having to start complying with rules that the EPA then set forth, then the Division of Drinking Water had then set. So we're slowly starting to catch up and gain our drinking water replenishment from our groundwater sources. So once that fully happens, and hopefully fingers crossed, at some point I'm assuming we'll probably have treatment at all of our wells. And so if there's any, hex chrome or anything else that gets thrown at us that we may see positive detections for, it's not something we're gonna have to worry about because we will have treatment at most of our well sites. And then that would be something if, depending on the funds and what would we want to pursue next, it is something we definitely want to pursue at some point.
Right, thank you. This next question, I could probably answer it. Are there any plans for any future discounts for seniors, medical baseline, and disabled beyond the rate assistance program discount? At this time, no. That is the only way we help to our seniors or veterans. That's $10 a month for 12 months, and it's a fiscal year application. So every year you do have to apply for that assistance. It's first come, first serve. So if you are interested or believe you may qualify for that, reach out to our customer care team and they'll be more than happy to walk you through that application. Um, yeah. And then just to also, since maybe you might be contacting customer care, you can also request the consumer confidence report from them if you want a paper copy. If not, you can always go on our website and actually look at the CCR. And we try to make it, full disclaimer, we have won awards for our consumer confidence report just because of how easy and accessible we've made that document, easy to understand. because we understand sometimes these graphs are just numbers. And we've tried to figure out a way to make it more engaging for our consumers. So please, if you have a minute or two, please look at that report. Okay, I don't see any more questions coming in. So with that, I think we'll go ahead and wrap up. Oh, okay, wait, we have another one. Yay, okay.
Yay.
Are bottled water subject to government regulations and periodic monitoring? Does bottled water have better quality than the
Okay.
water coming out of the tap?
Good question. Um, I would say historically, so kind of an overview. As a water agency, we are highly governed. So not only do we have to comply to the state, so the California Division of Drinking Water, which is the State Water Resource Control Board. So there's a full umbrella right there. Then we also have to comply with the federal EPA. And generally the federal is not necessarily as stringent, but California is. California always likes to one up in that sense. So we are much stricter than even what the federal EPA is. So you put that into perspective, it's very robust. The amount of sampling that we do every year is a lot. I mean, you can kind of go through the CCR, but we do thousands upon thousands of sampling every single year. FDA actually rules drinking bottled drinking water. So it's a separate entity. It is not state. They back in the day, they used to require, and this is from someone I know from an outside lab, said that they were required to sample certain constituents within the lab of different sizes of their water. So if you were to have one manufacturer and they had, 8 ounces, 12 ounces, 16 ounces, a gallon, all of those would have to be sampled twice a year. I've heard that they are starting to require more. I don't know if it's quite as robust as drinking water. Keep in mind, we're sampling our distribution system multiple times in an entire week. We got our tanks, we have our sample stations, we have groundwater wells, we have our surface water treatment plant. So we're covering all entities. I've heard they're doing more. To what extent of what they're doing, I do not know. So I cannot say they're any more safer or not. Yeah, I don't believe they're quite as heavily regulated, but I do foresee that they will be having, if they don't already, they'll be more regulated shortly.
Okay. All right. Well, I don't see any more questions coming in. So we're gonna go ahead and wrap up for tonight. I'm gonna thank you all for spending these last almost an hour with us today. And if you have any questions ever, you can always reach out to me or to Jenny. We're only a phone call away. You can email us as well. But we're just so glad that you were able to join us and you're interested in this. We're very open to having conversations. If you ever have any questions about your water, we're definitely happy to help. So yeah. Jenny, I will give you the rest of the time off now. Thank you for joining us tonight and showing and sharing your expertise on water quality with us tonight. Thank you and have a great night.
Thank you, everyone.